Welcome. My name is Joseph Idzorek. I lead product for Amazon DocumentDB. And today's webinar, we are going to talk about how to optimize cost when using Amazon DocumentDB with MongoDB compatibility. So what we're going to do is first going to talk about how pricing works for DocumentDB. It's hard to optimize for cost if we don't have the primitives down. So we're going to go through that. We're going to go through a lot of examples. I've created a lot of scenario-based examples just to hope make the points and the concepts more tangible. Then we're going to go into estimating costs. Once we've been able to estimate, then we'll go into monitoring. We'll go through quite a few examples there of different tools within the AWS ecosystem that you can use to monitor costs with DocumentDB and really a bunch of other services, not just DocumentDB, but we'll look at this through the lens of DocumentDB. And then we'll go through, each of the pricing facets for DocumentDB, instance, storage, I/O, and backup, and talk about how to do some common optimizations for costs there. And we'll have some open discussion about, different trade-offs. And I'll try to do as many demos as possible. I'm going to try to be in the AWS console showing versus talking about as much as I can. Okay, so first of all, if you're new to Amazon DocumentDB, what is it? Well, it's a fully managed, scalable, and MongoDB compatible database service. It's a document database, so it's really good at storing, indexing, and querying JSON. It's MongoDB compatible, so if you're running MongoDB workloads on-prem or on self-hosting on EC2, DocumentDB provides that really simplified, highly available, fully managed experience in AWS, so you don't have to run those workloads, right? So is a document database, right? What is document databases really good for? Well, they're really built to store JSON data, right? In applications, we typically model data as objects, which are inherently kind of key value pairs and nested JSON documents or nested JSON structures, and it becomes really convenient to be able to persist the data that you have modeled in your application in a database, right? Without having to do translations, right? Without having to say, hey, I have embedded documents in my data model, my app, and now I got to translate that to rows and columns to be able to store it in my database. Wouldn't it be just great if I can just store it in the same format and then retrieve it in the same format and reduce a lot of complication? Right, so document database is also, schemaless isn't the right word. Anything that has an index or field names or a collection name or a database name has schema, right? So really, it's about flexible schema, and there's not strict rows and columns, or sorry, it's not strict columns in which you have to insert data into. We really talk about document databases. It's schema on read, not schema on write, which means you can write a new field to a document, no problem. But your application has to be able to know that field exists. So the schema isn't enforced on the writing to the database, it's enforced when you read that on the database. And typically people find that to be a more flexible way to develop, is you don't have to make schema changes to the database just to insert a new field or a new row, if you will. Document databases are really good for ad hoc queries, right? They have a lot of flexibility to say, hey, I want to know, the cost of this particular widget in this region that was inserted at a particular date, or I want to sum the average min-max price for, these particular widgets, in the Northwest sales territory, or, how many auto policies have a driver that's less than 20 years old but been in an accident, blah blah. It gives you that ad hoc query ability that you can ask basically an unending amount of questions on your data. There's a lot of flexibility in the API. Flexible indexing, right? You can index JSON data, you can do single field, compound, multi-key indexes, you can delete them at any time, you can add them at any time. It's a really flexible model for that. And of course, you can do both operational, very give me the value for this, specific user, pull up this specific profile, or you can do those analytic workloads, right? Operational analytic workloads where you're doing summations and aggregations on the fly as well. So it gives you, really a lot of flexibility and a lot of power to be able to reason over your data. And that's really what's made document databases so popular. Okay, so we're going to talk about cost optimization today. And I'm going to throw a huge caveat in here and a disclaimer. For a few reasons. Every database workload is different, and what I'm going to talk about today may be everything I talk about today is specifically relevant to your workload, and it's going to be super useful, and you'll save a bunch of money. In the converse, maybe none of this is applicable to your workload just because you've already done all of this, or you're already at a good optimization point. I always try to find a good analogy for database workloads, but I kind of like to always think about it as like traffic in cities. So I lived in Manhattan before, and driving in Manhattan is a challenge, right? There's a lot of complexity going on. It's an interesting workload, right? Like, how do you drive, through Manhattan, to get out of the city? And I've lived in Ames, Iowa before, right? Ames, Iowa is a college town in the middle of Iowa that, has 40,000 people. And traffic is very different there. So if you think about just driving through those two cities as database workloads, they're incredibly different. And we see such a vast array of different workloads across all of our customers. Somebody that's doing, gaming profiles is going to have a different workload than someone that's doing IoT, that's going to have someone that's, doing genetic research versus somebody that's storing insurance policies. Like, these are all very different workloads. And the application of how you save on costs and how you optimize those workloads is going to differ. So that said, there's variance. Mileage, or the utility of what we're going to go through may be super applicable, it may not be, but I just want to make sure that we're upfront on that before we begin. All right, so how does pricing work in DocumentDB? Well, here's an architectural diagram for DocumentDB, and there's really 4 different components that we price for. One is on-demand instance usage, right? And we're going to go through examples of each one of these, so I won't go through too much detail in this slide. I just want to have a mental model or a frame here for us to think about these things and kind of reason at them as we go through these slides. The second one is database IOs, and these are reads and writes to the storage volume. Of course, if you're reading and writing to the storage volume, you're storing data in the storage volume, right? So that's the data that you persist. And of course, we want to back that data up. It's a good best practice. So then there's going to be a facet for how much we store or how much we charge for backup storage. So we're going to go through each one of these. And then I'll talk a little bit more in detail how these work. And then a little bit later in the presentation, we're going to talk about how we optimize for each one of these things and common things that we've seen across the number of customers that we work with. Okay, so on-demand instances. So on-demand instances are really, they're charged an hourly rate, and they're billed per second with a minimum of a 10-minute period of time, right? So it's a pay per reservation, right? So you're gonna say, hey, I want to have this instance. I'm gonna have it available for my use, and I'm gonna pay for it, I'm gonna pay for it, per second, but with a 10-minute minimum. So we're gonna walk through an example of what that looks like. So, and a lot of these I kind of have time, like a lot of these are kind of time-based. So like on the x-axis is time. So as we go left to right, time increases. So let's imagine at, at t0 or time 0, we create an instance. And then we say, hey, we didn't want to do that. So we're gonna delete the instance at 5 minutes. Well, how much do you pay for that particular instance? Well, because there's a 10-minute minimum, you pay for 10 minutes at, well, using a T3 medium at 8 cents an hour. So you pay about a cent for that, whatever 5-minute duration of having that instance around. Now, if you say, okay, well, I created an instance, but I deleted it after 15 minutes, well, how much do I pay then? Well, you're really then paying by the second of how many seconds of cost, or this is a nice clean boundary at minutes, versus a rate of 8 cents an hour. So you'd pay about 2 cents for that particular example. And why this is useful is if people have if people are deleting or adding instances or changing things on the fly, you don't have to round up to the common hour, right? So you wouldn't say in a traditional way, and how we actually, when we priced and we launched, we actually added this feature last year, we would have rounded all of these things up to 8 cents. So whether you use the instance for 5 minutes or 15 minutes, you would have paid 8 cents no matter what. So this gives you an optimization for creating instances that are on the boundaries of hours. Now, if you create instances and they're long-lived instances, say, hey, you created 2 instances at t equals 0, that's going to be, for each hour, it's going to be 2 instances times 8 cents per hour, which is going to be 16 cents an hour, which is the common use case, right? Usually, database instances are long-lived for production workloads, and then you pay on those things by the hour. Okay. All right, so now moving on to I/O. Now, I/O is database inputs and outputs. And friends, I'm also gonna caveat this one. Like I'm gonna use high-level abstractions for I/Os. They're a bit more complicated. I think in databases, I/Os and in query processing is probably some of the more complicated topics that are out there. I'm not trying to diminish anything or hide any details. I'm just trying to provide a high-level abstraction for for this conversation, just to provide a common frame for how we can reason about these and think about it. And I completely admit there's a lot more devil in the detail here, and we can definitely get into that at another time. So I/Os are about how much operations, right, input and output operations that the database, the instances, read from the storage volume, right? That's basically, you can think about it as a unit of data transfer, if you will, right? So I/Os for reads, right? These are reads from the storage volume are charged in 8K or 8 kilobyte units, right? So every 8K unit that's read from the storage volume is an I/O. And we charge per millions of I/Os, right? So if you can think about it, one I/O is a fraction of a penny. A million I/Os, at least in US East 2, is 20 cents, right? So 20 cents per every million I/O. Similarly, writes in DocumentDB, and this is a little bit different than some databases. DocumentDB only writes logs to the storage volume, not full database pages. So if you only make a small change, we don't write the whole. Typically, database pages are 8K or 16K. We don't write the whole 8K or 16K page to disk. We only write the log record for that, which is typically much smaller than the overall database page. So you get charged for the things that you write in I/Os to the storage layer, right? So reads from the storage layer and writes, and then that is a count that's basically divided by a million and then paid by 20 cents an hour, or 20 cents per unit for that. So that's how I/Os are charged. And we're going to get into more detail on how databases work with I/Os a little bit later in the presentation. All right, so we'll do a little bit now. This will set up a little bit later. So when you think about this, writes through the application go through the buffer cache, and a buffer cache is the amount of memory in the instance that is used to store information, right? Usually it's a lot faster to read from memory than it is to read from storage, and that's really, your instances provide that type of, quote unquote cache backed by the persisted storage volume. And also a query processor and all the good, query parsing, so that you can run queries really fast. Much easier to run a query from data in memory. So when you write to the buffer cache, and then it writes down to the storage. So that's one I/O, right? And when you read data out of the storage volume into the buffer cache, so that the application can read it, right? There's no such thing as like you can't perform operations on the storage volume without first reading it into the buffer cache. Same thing, you can't write directly to the storage volume without going through the buffer cache. That's the intermediate, and that's really where I/Os happen. And we'll talk about this later. Reads from once an item's in the buffer cache, right? You're not pulling it from the storage volume anymore, and it's cached there. Reads from the buffer cache don't cost any I/O, right? You can read, once you read y equals, the document for y equals 2 into the buffer cache, you can read it a million more times, and you're only going to get charged for that initial I/O to bring it into memory. So that's an important concept that we'll talk about throughout the presentation. Is the utility and the efficacy of your buffer cache based on your workload, and how that helps reduce I/Os. And then there's storage, right? So storage, you pay for the amount of data that is persisted in a cluster. Now, unique to DocumentDB is that we replicate data 6 ways across 3 AZs, but you only pay for 1 copy of your storage, right? So if you look at, or if you think about this, if you store 100 gigabytes of data, you're only going to pay for 100 gigabytes of data. You're not going to pay for 6 times 100 gigabytes of data, but for the value that you get, you still get that 6-way replicated storage across 3 AZs. Now, if you were going to go to EBS and replicate this, the cost for provisioned IOPS storage is 12 cents and 12.5 cents per gigabyte month. And if you wanted to replicate this, well, that's 6 times that cost, right? So that's 72 cents, give or take per gigabyte month to, get the same level of durability on DocumentDB. DocumentDB, you get that durability for 10 cents per gigabyte month, right? It's a really great deal for storage costs for the amount of redundancy, durability, and availability of storage that you get. For backup storage, backup is constantly streamed from the storage volume, and we charge per gigabyte month. It's 2 cents per gigabyte month, which is a pretty good deal for backup storage as well. And we're going to go into later in the presentation, we'll talk about ways on how to optimize for backup storage so that you can really get the most out of how backup is built and how it works. Okay, so those are the primitives, right? Those are the things that we charge for. Now, it's also, there's a few things to talk about here, features, and then we'll talk about support. When you think about when you think about using a database, there's one thing is what are the metered costs? And then there's kind of the peripherals, right? And this goes into what is the total cost of ownership and things that you should consider. With DocumentDB, there's no upcharges or commit spend or, anything like that to be able to use enterprise security features, right? Like you can use encryption in at rest, in transit, have role-based access control, be eligible for HIPAA compliance on a single instance T3 medium that you're only paying 8 cents an hour for, right? There's no like minimum thresholds or barriers to be able to use any CloudWatch metrics or any of these other additional features. Those are available to all instance types at all times. Now, features like auditing and profiler. So auditing is, you can think of it as regular database auditing. Now, what we do with DocumentDB is we actually, to remove those logs, same thing with the profiler, and I'll show a demo of that later as a slow query profiler. We actually move those logs to CloudWatch so that you don't have to query your production database to get access to DML logs or DML auditing logs or slow query logs. But when we do that, the CloudWatch log usage rates do apply. So those are pay per use when those those are pay per use per CloudWatch usage when those features are enabled. Both those two bottom features are disabled by default. But since CloudWatch metrics, we have over 40 CloudWatch metrics. Those are at no additional cost. Okay, the other thing to always to consider when you think about total cost of ownership is support, and it's always a very important part in sometimes underestimated part of both cost and overall importance to your overall bill. So there's some good information here. Support plans start as low as $29 a month or as little as 3% for enterprise support, and that factors into the total cost of ownership. Okay, so let's talk about estimating costs. Now, this is where we're going to try to bounce into some examples. Now, so there's kind of two ways to estimate costs. One, like all the costs are enumerated on the DocumentDB pricing page. So then you can say, hey, for this particular region, we're showing US to Ohio here. Here's how much per hour, these instances cost, or storage, or IO, or backup. The other way to, and you can, take these and throw them into Excel, and you can do all kinds of, fun math based on your workload. DocumentDB is also represented in the AWS Pricing Calculator, and that's actually on the DocumentDB pricing page, right? So let me go over there real quick. We'll go to the pricing page. In here, you'll find similar diagram that we just talked about below, some unique characteristics, and then we'll talk about, here's all the storage, or here's all the instance prices, and we can say, hey, what is this, what does this cost in Seoul? What does this cost in Northern Virginia? Then there's the storage and IO rates and backup. All right, so then we can go down to our pricing example, and then we can see that we have the AWS Pricing Calculator, right? So we can say, hey, let's just say we want to run a workload that has a T3 medium. We want to do, we can do 2 instances, right? We can show the calculation there, okay? And then for storage and IO, we think, we're going to spend 100 gigs, and we're going to do 3 million IOs a month. And then for backup storage, we think we're going to do 100 gigs as well. And then we can see the breakdown. We can try to estimate our costs and say, okay, well, that workload's going to cost me, $126 a month, based on these estimates. So it's a really helpful tool to be able to estimate given costs for a particular scenario. All right, so that is AWS Pricing Calculator and the pricing page, right? And those are great tools to be able to estimate costs. Now, every workload is going to be different, so those factors have to be taken into play. Of a workload may only do 1 million IO a month. A different workload might do 100 million IO a month, right? So those are things that are kind of dependent on each application. All right, so once you, and I'll kind of show each one of these things. So once you start, after you've estimated, and it's always really a good practice, especially as you're doing a POC and you're doing testing, is to go through and then, take your estimates and then actually see what the actual running cost is, right? Were your estimates close? Were they what you thought? And that helps you gauge a bunch of things that we're going to talk about that you might be able to use to optimize. So the first thing is in your billing detail. We're going to go in there in a second, and we're going to, we'll go look at that, right? So we say, hey, and this is the most high level, way of looking at your data. And the good thing is you can say, okay, in Northeast, in US East, I'm paying $700 a month for DocumentDB. But what that doesn't tell you is, well, what cluster is that all from one cluster? Is that all I can see that I have this IO charge, right? I used 8 million IOs. It's cost $1.71. But imagine if that was a much higher cost. Is that all coming from one cluster? What's happening there? So it gives us a very high level overview, but it doesn't give us the ability to zoom in. And that's what we're going to talk about in a little bit.
One of the really nice things, and kind of one of the best practices that we definitely encourage, and this is in CloudWatch, and we'll go take a look at this, is how to set a billing alert. And billing alerts are super useful because, as folks that are pretty accustomed to AWS, is you don't get your bill until 4 days after the turn of the month. So if you blew through more usage than you thought, on day 5 of the month, you're really not going to figure that out for another 30 days, right? And this is where people get, surprised with their bills, and we don't want surprises. So one of the things I always do on my accounts is set up a billing alert, right? So let me go show you how to do that.
So let's go into the AWS Management Console, and I'm going to go to CloudWatch. Now, I've already set up one before, but I'll walk you through the process of doing this. So if you go into alarms, right, we can say, hey, let's click on billing. And let's create an alarm. And I'm going to select a metric, and that's pretty nice. I can go right down here to billing by service, and I can choose DocumentDB, right? And I can select that metric. And then I want to say, let's go for a period of 1 day, maximum value, static threshold greater than, hey, I want to know, if this is more than $4,500, I think that's the threshold I want to set at, because I'm going to be surprised if at the 5th day of the month it's already done that. I'm going to select an ARN SNS topic. Let's see, I'll send it to DocumentDB. They'll email me. Right, give it alarm name. Surprise. Oops. Please take action. I can't type today. All right, and then we hit next, and then we can see that we've already eclipsed that particular alarm, right? So I'm going to get an email right away from this. So I can go look at this one that I set up earlier, and you can see hey, I actually set the threshold at $5,000, and we're on the 13th of the month when we're recording this. So I'm going to get an email pretty soon for this particular alarm, and that's going to be a good thing because that will allow me to go in and then evaluate what's going on in my cluster, and if things are aligned with what I thought they would be. All right, so that's billing alerts, and I would we definitely suggest that 50% and 75% of expected costs. That's a really good way to not be surprised. Now, what I hope you're saying is, Joe, that's great, but that's the aggregate bill for an AWS region for all of my DocumentDB usage. I have a lot of stuff going on how can I look at things at a cluster level, at an hourly cluster level, and isolate some of these workloads? Well, there's a really great feature called cost allocation tags. And I'll go through and I'll show you this guy, and show you first what it looks like, and then we'll back out of it and show you how to do it. So cost allocation tags allow you to be able to tag AWS resources, so in DocumentDB, clusters and instances, and then be able to do these really advanced billing reports based on the resources or the billing that's actually going on for that particular tag. Right, so you can do by environment, you can do by an individual cluster. There's a lot of fun stuff we can do here. And I already have a report set up ahead of time, so I'll just kind of show you like what the utility of this looks like. Right, so right now I have a cluster in US East Virginia, DocumentDB, and I've tagged both clusters and instances, and we'll talk about that in a little bit. And you can see my hourly usage for the last day is pretty consistent, right? I have 2 T3 medium instances. I have a little workload running on this, which is a little canary that I wrote, and it uses a little bit of storage, and that's pretty consistent workload. But let's go out to say not hourly. Let's go back to, let's look at this for a little bit longer time period. So let's say we start on July 31st, and we go and look at the last few weeks. And then we're gonna say, oh, we probably don't wanna look at hourly. It's probably a little bit too much data for us. Right, it's kind of dense. So let's look at daily. Let's look at what these daily costs look like. All right. Right, and then we can say, oh, okay, interesting. So now for this particular cluster, I went, actually went and evaluated that, hey, my costs were a little bit higher. They're a little bit more than I wanted them to be. I was actually using, I was just using this cluster for, dev test workload, and actually scaled down to T3 mediums. And now we can see kind of the reflection on the daily cost across the different dimensions. And, there's a bunch of stuff that we can do here. So let's go back into DocumentDB, and I'll kind of show you how this actually works. One thing I wanted to point out is that there's a whole blog for cost allocation tags for DocumentDB on the resources page. Now the resources page is a really great way to find a really consolidated view for DocumentDB of what are the recent announcements and also what are the recent blogs. Right, so we can say, hey, you can say, hey, here's the launch for T3 mediums, here's the launch for cross-region snapshot copy, but also here's all the blogs that we've posted recently, right? So using cost allocation tags or profiling slow running queries, these are a really great way to learn more information. So let's go in here, and I have a cluster called scale demo. Now in DocumentDB, there's kind of two different there's really two different parts to this, and I want to make sure that these are clear. Is DocumentDB, one of the really unique advantages of DocumentDB's architecture is we separate storage and compute, but they're actually so much separated that they're actually physically different entities, right? And this allows compute or the instances to scale independently of the storage. So why this matters to cost allocation taking is you actually have to take each of them independently, right? So we'll go into a cluster, we'll do scale demo, and we say we want to be able to do monitoring for this particular, or we want to do cost allocation tags for this particular cluster. I'm going to go to events and tags, and I'm going to add a tag. And I'm going to call this one, I don't know, let's make something up today. We'll say this is our staging environment, right? We'll call this staging. And then so for cost allocation tags, although for most key tagging things, the key or the value is optional. For cost allocation, it is absolutely required. If you don't put this in, it won't work. So we'll call this cluster, right? So we'll call staging is the key, and this is cluster. And then we'll save it. And then we want to go tag our instances too, right? And then so we'll say, okay, cool. So we have our cluster, and a cluster is basically a namespace and a storage volume. And then we'll go into our instances. And this is our scale cluster. So I'll do one, I won't do all of them. So I'll click on this guy. And in similar interface, right, we'll go in and we'll add a tag to one of the instances in this cluster. We'll call it staging, and we'll call this one instance, right? That's the optional value. We'll hit save. All right, so then if we want to go into our billing dashboard again, to enable this, we'll go into cost allocation tags. And then we'll go in here and we'll say, hey, staging, right? And we'll see this key. It's not activated yet, so we have to activate it. Yes, I would love to activate it. And then it can take up to 24 hours for this to activate. So when you do cost allocation tagging, it's not immediate, right? Usually there's a lag of 12 to 24 hours, right? So let's go back to this guy. So once we come here, and I've already used a tag, I just want to show you how this works. So if I click on my tags, the one that I'm using here is test environment, and I have clusters and instances. If I want to just get rid of cluster, which would be storage, IO, and backup, I can apply that filter. And now I can just look at, hey, this is, I'm only looking at instance costs here, right? And I can say, hey, I want to look at the total ownership for a cluster. So let me actually go back in now and say, hey, just like we had done before, we did both clusters and instances, and I can apply that. Right, and this gives you a lot more flexibility, and you can do tags per environment, so you can say, hey, take all the clusters in my prod environment or all my clusters in my staging environment. So, so that's super useful. Now, the next level, and I'm not going to show this one, but the next level is being able to set up budgets. And budgets are, if you kind of think about we're kind of narrowing down here, budgets are basically alerts for cost allocation tags. So you can say, hey, I want to set a budget based on these resources that are tagged here. So for this, but instead of doing billing alerts at the region level, you can do basically billing alerts at the tag level. So you can say, hey, for this cluster, I want to set a budget, and I want to stick to that budget, and I want to be able to set alerts on that, right? So for this one, my budget's at $400. Right now I'm at actual, and I'm 90% under budget. And if I do go over budget, I'm going to get an email. So these are really great ways to monitor cost. Okay, so optimizing for cost. Again, results will vary. So for instances, so DocumentDB, because the architecture, the storage is separated from the compute, your data is highly durable, whether you have one instance, two instances, three instances. The durability is not a function of how many instances you have. And this is different than traditional database architectures. So you can actually have a one instance cluster for dev test, right? It's not, we wouldn't consider this, really highly available, but you're not going to compromise durability. So we see this as a very popular option for people to save money on dev test workloads, but not have to worry about the durability of their data, right? You're still going to get 6-way replicated storage across 3 AZs, whether you have one instance in your cluster or 16, right? You can certainly always add instances, increase availability, and increase, read capacity in your cluster, and then to be able to fit your needs, right? So that's super helpful, right? Because then you can actually, you can say, hey, this is an interdepartmental website. I don't need 4 nines of availability. I only really need 2 nines of availability. So now I can cut my instance cost by 1/3, so I can match my workload, and I don't have to compromise durability to do that. There's a lot of advantages in flexible cluster sizing for that. Another feature that DocumentDB has that allows folks to be able to save on instances is start stop cluster, right? You can stop a cluster, which will basically bring the instances and IO down to $0 when the cluster is stopped for up to 7 days. After 7 days, we automatically restart your cluster. And the reason we do that is if there's maintenance or any other type of patching events that happen, that it happens within a reasonable time to keep things up to date and patched accordingly. But you can always stop it again after that. So I'll just go show you in the console what that looks like. Right. So I have clusters, and I have one that's stopped right here. Right. It's a one instance cluster. It's stopped. That means I'm not paying for for the instances, and because I don't have any instances, I can't be generating IOs. Now, I'm still paying for the storage and backup for this cluster at normal rates, but I'm not paying for the instances. So I can go in and say, hey, I want to be able to stop this cluster, right? It's Friday. I'm not going to work on this cluster over the weekend. Why do I want to pay for the compute? So I'll hit stop there, and I can stop that cluster. And that's a really great way to save money. Now, indulge me, if you will, I'll kind of go through this peeling of the onion type scenario and say, hey, as we looked at in the cost estimator, let's just say we had a 3-instance, cluster, T3 medium at 720 hours in a month at, 0.078 cents per hour. Total cost, $168 a month. But you might say, hey, Joe, well, this is a dev test workload for me. How do I save money on this one? Well, first thing I would say is, do you need 3 instances, right? Is if you're just kind of doing functional testing, and, can you remove 2 of those instances and still highly durable, but, maybe you don't need, 4 nines of availability for dev test, right? So from there, you remove, and like the picture on, or the diagram on the right basically shows you what you're paying for throughout the month. So let's remove 2 instances. Right, you reduce 67% of your costs, and now that cluster costs $56 a month. Okay, but I still don't want to pay $56 a month for a cluster for dev test. Well, if you're not dev and testing on the weekend, it's super helpful to be able to stop that cluster on Friday when you leave the office, or when you just leave your desk at home, I guess is the correct statement at this point in time. And you don't pay for that over the weekend, right? So then you can save all of those hours. If you think about, like, hey, if folks are working 40 hours a week and there's, roughly 4 weeks in a month, but there's 730 months, that's you're only working 160 out of 720 hours, and you're not paying for the compute. You can save a lot of money. And we definitely see folks scripting this out. And we, I definitely see this behavior repeated often. Right? And same thing, if you're not using your cluster at night, you can definitely stop it then as well, right? And it takes about, anywhere from 5 to 10 minutes to start your cluster up again in the morning. It's just re-provisioning basically the compute. So about the time it takes to go get a cup of coffee, your cluster will be up and running again, right? So you can take a 3-instance cluster, save about 93% on it by using start, stop, and single instance clusters for dev test, and then bring that down to, about 12 cents, 12.50 a month to be able to run a dev test workload. So that's where the flexibility and starts up cluster really help you optimize for cost. And of course, there's also flexible instance sizing. One of the, the really great advantages of DocumentDB's architecture is it's really easy to change instance sizes. It's because storage and compute are decoupled. When you want to change an instance type, you don't have to copy any data anywhere, right? It gives you a lot of flexibility. They're decoupled, right? Such the fact that, if I want to, I did a demo at reInvent last year, added an instance in 3 minutes on a 1.5 terabyte cluster, right? On traditional architectures, that's just not possible because you have to copy 1.5 terabytes over to that instance because of attached storage volume. But on this type of architecture, we separate storage and compute, super easy, right? So I have a T3 medium cluster, I can scale those things up to R5 larges. I can scale one instance up to an R5 12x large. I can get rid of that and delete it if I don't want it. I can add 4 instances. It gives you a great amount of latitude to be able to optimize this for your particular workload or your particular scenario. The other thing that's worth noting is DocumentDB, we don't charge for replication between instances or even the bandwidth. So we charge for IO to the storage layer, but we don't charge for any bandwidth between there. And it's just a nice thing that one less cost you have to think about and model out and try to estimate. All right, so let's go into IO. So with IO, reduce IO, you want to try to fit the data into memory, right? That's one of the big objectives with reducing costs for IO, because if you're reading from memory and you're not reading from disk, you're not paying for those IOs from disk, right? So, let's just imagine our application, reads this data from disk and we're reading these documents. Any subsequent reads of these documents are going to be read from memory. So it doesn't, doesn't cost us any IOs. Now, the second we want to, we just filled up our buffer cache. Now, the second we want to read a new document, well, that's going to have to come from the storage volume. We're going to have to evict probably, one of the items that are in our buffer cache so that we can put that new document there. And that's where IOs for reads come in, right? So we have a CloudWatch metric called buffer cache hit ratio. And this is, this is definitely dependent on your app, right? Different apps have different characteristics between, performance and cost. But generally, it's desirable to have as close as amount of reads as possible come from the buffer cache or the memory on the instance. And the reason for that is reads from memory are going to be a lot faster if the data is already there, and you're not going to pay for the I/O because you've already paid the one I/O to get the data in memory. You don't have to pay subsequent I/Os. Now, database is a little bit more complicated than there's data pages. You also have to worry about indexes, right? Indexes have to be pulled into memory as well, right? So when we think about this, not only is your data, it's good to have your data in memory, it's also very good to have your indexes in memory, right? Because if you're constantly trying to be able to read a data page, you have to go and read an index, you're going to cause a lot of I/O. Right, so we also have a CloudWatch metric that is the index buffer cache hit ratio, and this will tell you how many of your indexed reads are coming from memory, and that's a really good indicator to see if your workload is properly sized for your instances. Now, ideal work closest to 100% as possible, but every workload is going to vary. Maybe somebody at 80% is going to be perfectly fine. It's going to be subjective based on your application. But if you're reading your data in indexes both from memory, you're not paying for I/O, and that's a good way to optimize. Now, so that's on reads, right? Indexed reads are really good because they help speed things up, and we're going to go through an exercise here in a little bit. But indexes, there's no free lunch, right? Like if you're going to have indexes, you also have to pay for storing that data. So let's just say we have a document that has 4 fields, and you've indexed each of those fields. What happens from a write I/O perspective when you insert a new document? Well, in your collection, whatever, db.foo.insert, in foo, you're going to store that whole document. So that's one write. You have an index. Every document has an underscore ID index for the object ID, or you can override it. You're going to store a copy of the data, item equals ruler, for you've indexed every field in this document, right? So now you have an index for item, you have an index for colors, you have an index for inventory, and you have an index for price. So now writing one document, you now have 6 different writes you have to make in the database so that all the indexes are populated. Right, so there's no free lunch. Like indexes certainly do help speed up reads, no doubt about it. But we also have to think about being frugal with, how many indexes you create on a collection and what is the impact to that on your write I/O path. What is on write latency and write I/Os, right? So, we really think about, as a rule of thumb, and this is, mileage is going to vary again, is thinking about having 5 or less indexes on a collection. We've certainly seen scenarios where, customers have 20 indexes on a single collection, and that works for them. And some, folks, it doesn't work for them. So when we have that happen, what we usually ask folks to do is say, hey, take a look at your unused indexes. In this case, there's an aggregation stage called index stats that will tell you for your indexes how many operations have occurred on that index and since when the last time the instance was rebooted. If you have an index that's been around for a long time and has never been used, you want to probably remove that index unless you have a good, anticipation that you're going to use it. Sometimes indexes are created on good intentions, but they're never used. If you have a bunch of unused indexes, remove them. You're going to save on storage costs. You're going to save on write costs as well, because you don't have to write, to all n indexes if you're never using them. The same is true for reads. Now, for reads, I want you to think about a scenario that you're going to read. I'm going to give you a 1,000-page book, War and Peace or Atlas Shrugged or whatever the case may be, and I'm going to give you the task of I want you to read through every single page and tell me what pages, bring back the pages that contain the word tags. And you're going to say, woo, okay, so you start on page 1, you look through page 1, then you go to page 2, and you go to page 3. And in databases, if you're going to do this in a database, we call this a collection scan, right? Basically, you're going to read every page in the book looking for that particular field or that particular world tags. And to do that, you're going to go through a lot of I/O because you have to read every single one of those pages. And every time you read a page, if it's not in memory, that's an I/O. This is where indexes come in, right? Like if you think about the analogy in the back of a book, Indexes allow you to go directly to the pages that contain the words you're interested in, right? And it cuts down on the I/O significantly, right? So if I gave you the task of, okay, we'll use the index in the back of the book and go show me the, the contents, bring back the pages that have the word tag. That's called an index scan, right? So you would just go to page 232 and 292, and that would be it. We would just do that super fast. And the point here is if you're doing a lot of queries, that are collection scans, you're going to be or basically for point lookups, you're going to be doing a lot of I/O, reading every page in the book, when an index would allow you just to go directly to those pages and save, instead of doing 1,000 reads, you would only do 2 reads. So that's the there's a balance there. You can over-index things, you can under-index things, and those things are going to be dependent on your application. Right? So you definitely want to have indexes on common, common predicates or common filters that you use for your queries. Now, what operations use IOs? Well, really anything that needs to read data and indexes from the storage volume, right? Any commands, CRUD operations, aggregation queries, those all are going to use IOs one way or another. TTL index deletions as well, right? If you think about TTL indexes, definitely read and delete data as well. So that's going to cause IOs. Change streams, right? If you enable change streams on your cluster, which is a change data capture feature, every time you write new to that change stream, that's going to be an IO. And if you read from that change stream, that's going to be an IO as well. And then certainly utilities like Mongo dump and restore. If you take a full dump of your cluster, that's certainly going to use IO because you're going to be reading every single bit of data from your storage volume and then write that out to say an EC2 instance or an S3 bucket or whatever. So that's going to cost IO well. What are things that don't use IOs? Well, reads from the buffer cache, right? Like that's really, reads, and that calls for both data and indexes. That's where we really want to get as much data in the buffer cache as possible. And if you have low buffer cache hit ratios or index buffer cache hit ratios, you probably want to scale your cluster instances up. And a common conversation that we have is, well, isn't that going to increase the instance cost? And this is where this is where the math comes in and saying, well, yes, you'll increase your instance cost, but actually the total cost of the cluster might actually be reduced because you're going to reduce, you can spend more money in IO than you can in instance costs. You might reduce your IO such that you actually save more money overall by increasing your instances. And the other thing for DocumentDB is service managed backups. Because they don't use your compute, because of the separation of storage and compute, you don't use any IOs for point in time restore or taking snapshots. And so that way you can save, those are ways that you're indirectly saving money, is you don't have to take those really expensive operations and use up your valuable IOs. All right, so one of the things you might have recognized if you created a DocumentDB cluster before is that when you create a cluster, there's nowhere where you tell us how much storage and IO you want. Right? There's no like, hey, I want to pre-provision 100 gigs or half a terabyte or 10 terabytes, whatever, or this many IOs. And the reason for that is DocumentDB, different than instances, the storage and IO actually auto scale. So you start off with 10 gigs, and based on how much storage you use, right, it actually grows. Now, just want to caveat is it doesn't shrink back down. So there is a high watermark, but as you grow data, and like a vast majority of workloads grow data, it'll grow with your workload at 10 gigabyte increments without you having to provision anything, which is super useful. It's not a very desirable thing to have to do capacity management for storage. Same thing with IO, right? It's pay per use IO. If you don't use any IO, you don't pay for it. But if you use a bunch of IO, then you pay for a bunch of IO without having to say, hey, let me figure out what my what 100% of my spike for IO is this much, and let me provision 10% or 20% more than that. And now I just, used a whole bunch of, I provisioned a whole bunch of IO that I know I'm not going to use. IO and DocumentDB is pay per use. Now, one of the things, and this is, this depends on your workload, certainly. One of the things you can think of, how do we reduce storage size? Well, one of the things that we commonly see is in field names, right? Sometimes people like to use very verbose field names, item name, item color, current inventory on hand. If you only have 20,000 documents in a collection, not that big of a deal. If you have 3 billion, 3 billion documents in a collection, and you can save 25% of the characters in the field names, because all the field names have to be stored with the documents, by using item or color abbreviations, you can significantly reduce the size of your documents. And that's a really good way of looking at it. So you can think, like, these are very trivial examples, but you can imagine, customer workloads that have hundreds of fields with very verbose descriptions. You can actually reduce quite a bit of storage and I/O too, right? Smaller documents, less I/O. Now this one's a discussion, right? So take this with a grain of salt. Data modeling. Now, document databases are supposed to be, one of the key kind of design patterns is denormalized data, right? Versus normalization, which really is trying to reduce deduplication in data and smaller storage size. But if you think about a denormalized data model, you're going to have repeat content, right? Like, although there might be multiple, restaurants in Austin, you're going to store this information with every restaurant, right? That's an example of denormalization. Now, one thing I want to kind of talk about here in data model designs is you can definitely go overboard with denormalization, right? So I want you to consider a scenario where we have review count, right? In this case, it really, there's 46 reviews, and these reviews are stored in another collection, right? So I don't have all the reviews stored in this one document, right? I have 2 collections that one tells me how many I have count, so that when I pull up this profile, when someone goes this on a mobile site, it's super fast and snappy, right? Like it's a really small document. But we've seen scenarios, and this does happen, where people say, hey, I just want to put everything in one document, right? I'm going to denormalize this to the nth degree. And every single review is an item, is a document, is an item in an array. And you can imagine, sure, it's going to be probably a smaller overall size because you're reducing the duplication of data, but this is going to grow unbounded, right? Which is going to decrease the performance of every time you have to, pull that particular array, or sorry, this particular document when you, just want to be able to display something that, just the information for that particular restaurant, right? So usually when you think about these things, is categories is kind of a bounded thing, right? Restaurants have a limited amount of categories. When you start to get into things that have unbounded number of items, such as like a review, right? That could go to 4, maybe this becomes the most popular restaurant in Austin, and now that's 10,000 reviews. You don't want to store that all in one document, right? This is where you want to kind of normalize that a little bit and store it in its own document. And this is, these are areas where you can be, pound, or what is the expression, penny wise and pound fool, saying like, hey, we really want to, cram all this storage in there and save, I'm just going to make some numbers up, $10 a month by doing this. But you're going to, like, the human hours to do this and the complication, all the other thing might be way more valuable than trying to save on storage. So these are different things to take into account when you're modeling out your data. And lastly is backup costs. Now, backup is, we're going to go through these examples. We'll go through these examples in a diagram. So there's no additional cost for backup and storage to 100% of your total cluster in a region, right? So if you have 100 gigabytes cluster in a region, you don't pay for any backup storage under 100 gigabytes. You get that for free. Same thing as there's no charge for backup storage if your retention period is 1 day and you don't have any manual snapshots. And we're going to go through some diagrams to help out. Why that is? Well, backup in DocumentDB is on by default. You can't actually turn it off. We'll give you 1 day for free, right? And why we do that? Because we really believe that databases should be backed up at minimal for a day, and because you never know when something's going to happen. So to offset that, we give that to you for free. So in this example, there are automatic snapshots which happen automatically in the cluster, and then there's manual snapshots, and those are ones that that you trigger. So in this example, we have a retention period, which is 1 day, and we have a backup window, which is just a period of time in the day in which we take these automatic snapshots for you so that you can trigger workflows. It was a feature request that folks wanted so they can trigger workflows once a day based on these automatic snapshots, right? So in this scenario, you don't pay any additional cost for backup. Basic backup is free in this scenario. Now, if you had taken a manual snapshot the day before, that's outside of your retention window, and that backup will be charged, for a full cluster backup. All right, make sense? Okay, so going a little bit further, the maximum cost for your backup storage is up to the size of your storage volume, right? So it's a little tricky, this is where we use diagrams to explain it. It takes a little bit to synthesize. Manual snapshots outside the retention period are billed at full cluster as full cluster snapshots. So let's kind of consider this scenario. In this, we have a 4-day retention period and we have one manual snapshot. The maximum you're going to pay in the first scenario is up to the size of your cluster for that storage. You have 4 days of the ability of point-in-time restore and a manual snapshot that's within the retention period. But the maximum cost is up to the storage volume for the cluster, right? So 4 days of point-in-time restore. The most, if you have a 100 gigs cluster, the most you're going to pay is 100 gigs of backup storage for that. Now the scenario below it, once that manual snapshot falls outside the retention period, now you're going to pay for, let's say, the 100 gig snapshot, manual snapshot, and then, maybe up to 100 gigs for the retention period storage. So that's, potentially the maximum value there is 200 gigs. Now, if your workload in your use case is like, hey, we take these manual snapshots all the time, we take them once a day for a 2-week retention. Well, in this scenario, you're going to pay for 4 manual snapshots at let's say at 100 gigs plus, the storage within the retention period. So you might pay up to 500 gigs of backup storage in this case. If that's your workload, friends, do this. Extend your retention period, right, to the point where you want to have those snapshots. Once it's under the umbrella of the retention period, the most you're going to pay is up to the size of your storage of your cluster, which is 100 gigabytes. Right, so that's a great way to be able to optimize for cost based on your usage, is really maximize that retention period based on your backup strategy. All right, so in summary, what we talked about today was, how does pricing in DocumentDB work? We talked about how compute, storage, I/O, and backup work and how they're priced. We went into the DocumentDB pricing page and the AWS Pricing Calculator to estimate costs. And then once we estimated costs, we went through the AWS billing console. We went through, kind of aggregate bills. We went through billing alerts in CloudWatch, talked about cost allocation tags, and then showed, through budgets how we can actually, create alerts on cost allocation tags. And again, cost allocation tags allow us to do much more granular reporting and monitoring of costs at even a cluster level versus aggregate in an entire region, which you get with your billing. And then we talked about how do you optimize costs for different use cases in different facets of DocumentDB that include instance and storage and I/O and backup. So we went through quite a few ways. I hope that this content was useful for you and it helps you optimize some of your workloads to save a little bit of costs. And appreciate the time. Thank you.